This recorded presentation is on atomic structure and chemical bonds. So like I said, the lecture topics are the structure of atoms and chemical bonds, and here are your learning objectives for the structure of atoms. You need to be able to describe atomic structure, meaning the location and charge for protons, electrons, and neutrons. You have to be able to explain what an element is, define the terms atomic number and atomic weight or mass, and define the term isotope. So we talked briefly about matter when we looked at the levels of biological organization. So I want you to think back on that lecture and come up with a definition of matter to yourself. So remember that matter is anything that takes up space and has mass. So matter can be living or non-living, but it's any type of object. Now there are three states of matter. And there is gas, liquid, and solid. So for instance, water vapor that forms clouds or fog is also considered matter. Now what you learned before is that the atom is the smallest unit of matter. So all matter is made up of atoms. So there are three subatomic particles that you need to know about. So there's actually more than three subatomic particles, but these are the ones that you need to know. So there are protons. They have a mass of 1 atomic mass unit. So we'll just say mass is 1, and a charge is positive. Neutrons also have a mass of 1, but they do not have a charge. They are considered neutral. That's how I remember neutrons, neutral, protons, positive. Then we have electrons. Their mass is negligible, meaning that it is not significant because electrons are so small. And their charge is negative. I'm just going to write that negative sign. Now, one of your learning objectives is that you have to know where in the atom these subatomic particles are. So if you look at the animation I showed you here, what you see moving around on the outside are the electrons orbiting the nucleus. And the nucleus is made up of protons and neutrons. Here is the periodic table of elements. So now we are going to talk about what an element is. So there are 118 elements that we know of. 92 of those are naturally occurring. Now there's only about 30 elements that you find in living organisms. Your learning objective is to explain what an element is. If you look on the periodic table, we have carbon over here, nitrogen, oxygen, hydrogen. You've probably heard of these elements before. So an element is a substance that cannot be broken down and maintain the characteristics of that element. So for instance, hydrogen is normally in the gas state in room temperature. That is a characteristic of hydrogen. So you cannot break a hydrogen atom down and still retain that property. So when we talk about atoms, every atom is an element. We have a carbon atom, an oxygen atom, a nitrogen atom. So how do we know what type of element an atom is? So an element is an atom with a, I'm going to say, characteristic number of protons. Look at the periodic table where my cursor is. We have carbon. Right here is where I'm looking. Carbon has the number 6 above it. 6 is the number of protons. So every carbon atom will have 6 protons. If it doesn't have 6 protons, then it is not carbon. Here is an entry on the periodic table of elements. And again, I'm looking at carbon. One of your objectives is to define atomic number and atomic weight. You can see in the image here, it says atomic number, and there is an arrow to the number 6. Atomic weight or mass, there's a slight difference between weight and mass, but for our purposes, we will use those terms synonymously. Here we have atomic weight. Atomic weight says 12.01. So atomic number is the number of protons. And I'm going to write the example here. Carbon has 6 protons. Atomic weight or mass is the number of protons plus the number of neutrons. Remember that I told you protons have a mass of 1, as do neutrons. So think about how I can figure out the number of neutrons by looking at this entry in the periodic table. So what you should have come up with is that the neutrons can be determined by taking the atomic weight and subtracting the atomic number. So number of neutrons is the atomic weight minus the atomic number. For carbon, there are 6 protons and 6 neutrons because you are taking 12 minus 6, which obviously gives you 6. Another thing I want you to remember, when you are looking at an element in the periodic table, it is referring to the stable atom, meaning protons equal electrons equal neutrons. So I'll show you why that means a stable atom. 6 protons means you have 6 positive charges. 6 electrons means you have 6 negative charges. They cancel each other out so that the net charge on your atom is 0 or neutral. You do not have a charge. That's why we call it stable. So a stable atom, protons equal electrons, which equal neutrons. So for carbon, we have 6 protons, 6 neutrons, 6 electrons. That is the stable atom. This next slide is showing you an isotope. Take a look at these 3 carbon atoms and determine what is different between these 3 atoms. What you should notice, they all have 6 protons. If the atom does not have 6 protons, then it is not carbon. However, this carbon atom has 6 neutrons. This one has 7 neutrons, and this carbon atom has 8 neutrons. So an isotope is an atom that has a different number of neutrons. I'll write that definition for you. So atoms of the same element that have different numbers of neutrons. So we call this first atom carbon 12. This is your stable carbon. 6 protons, 6 neutrons, 6 electrons. The middle carbon atom is carbon 13 because there are 6 protons, 7 neutrons. And then finally, we have carbon 14, which has 6 protons, 8 neutrons. So an isotope is an atom of the atoms of the same element that have different numbers of neutrons. Carbon 12 is the most abundant carbon atom in nature. And then we have carbon 13 at a very small percentage and carbon 14 at an even smaller percentage. I'm going to stop here for the video on atomic structure, and my next lecture video will go into chemical bonds.